Horten Ho 229, also known as Ho 9 or Gotha Go 229, is a unique German prototype from World War II that is often called a plane of the future. It was created by brothers Reimar and Walter Horten, aviation enthusiasts fascinated by the idea of a pure flying wing. For its time it was a revolutionary project, a jet fighter bomber that was decades ahead of its era. The idea did not appear by chance. In 1943 Germany launched the 31,000 program, to create an aircraft capable of carrying 1,000 kilograms of bombs for a distance of 1,000 kilometers at a speed of about 1,000 kilometers per hour. Such a machine was supposed to break through Allied air defenses, deliver a strike, and get away while remaining practically invulnerable. The Horten brothers proposed their solution, a flying wing without a fuselage, where the entire space was taken up by a load-bearing surface. The design was unusual. The central section of the Ho 229 was made of steel tubing and housed the cockpit and two Junkers Jumo 004 jet engines. The wings were made of wood and plywood, partly due to the shortage of aluminum, partly because wood reflects radio waves poorly. This later gave rise to the legend that the Ho 229 was the first stealth aircraft in history. And although it was not invisible in the modern sense, 21st century research showed that its radar visibility was indeed lower than that of standard 1940s aircraft. The first Ho 229 glider took to the air in March 1944, but without engines. Its flying qualities seemed promising. The aircraft was fast and maneuverable. In February 1945 the first jet-powered flight took place. Unfortunately it ended in tragedy. One engine flamed out, the other overheated, and the aircraft crashed. The pilot, Erich Ziller, was killed. This greatly slowed the project. Despite the problems, the machine's potential was striking. Theoretically it could reach speeds of up to 950 km per hour, comparable to the first jet fighters like the Me-262, while having a greater range and being able to carry a substantial payload. The planned armament was 4 30mm cannons and up to a ton of bombs. Had the Germans managed to launch production of at least 100 such aircraft in 1944-1945, the air situation over Europe could have become far more complicated for the Allies. But the project had too many buts. First, the Jumo 004 engines were extremely unreliable and failed frequently. Second, the aerodynamics of a flying wing without modern computers made control very difficult. Pilots had to fight instability almost constantly. Third, by the end of the war Germany simply lacked resources, the country was barely holding on, and costly experimental projects were a luxury. After Germany's capitulation, the remaining Ho 229s fell into Allied hands. One of the prototypes, V3, was taken to the United States, where it later ended up in the collection of the Smithsonian National Air and Space Museum. In the early 2000s engineers carried out computer modeling and even built a replica to test its stealth qualities. The conclusion was interesting. The aircraft indeed had reduced radar visibility for the radars of that era, but calling it completely invisible would be an exaggeration. Today the Horten Ho 229 remains a symbol of the Third Reich's lost technologies, projects that could have changed the course of the war but appeared too late and never came to fruition. It is often compared to the modern American stealth bomber B-2 Spirit. The similarity in form is obvious, although nearly half a century of technological development separates them. At the beginning of the 1940s Germany was in acute need of a new type of aircraft. Massive Allied bombing and increasingly effective air defenses demanded a machine capable of flying faster, farther, and carrying a heavier load than existing fighters. In response, the German Aviation Ministry formulated a requirement known as 31,000. The aircraft had to carry 1,000 kilograms of payload, have a combat radius of about 1,000 kilometers, and reach a speed close to 1,000 kilometers per hour. The goal was to create a fast strike or interceptor aircraft that could penetrate the escort of Allied bombers, hit strategic targets, and egress before effective countermeasures could be brought to bear. To meet this task, the Horten brothers proposed a pure wing scheme, with no tail section and all usable space integrated into the wing. This design promised better aerodynamic efficiency, less drag, more volume for fuel and equipment, and therefore higher speed and range for a given thrust. The practical task was to create a combat aircraft combining the characteristics of a fighter and a bomber, intercept heavy enemy bombers, break through dense air defenses, and conduct long-range raids on key targets. These requirements imposed strict constraints on the design and layout. Engines, fuel tanks, crew, and weapons had to be placed inside the wing while maintaining stability and controllability. In addition, by the war's end there was a serious shortage of aluminum and other materials, so the task included working with available materials, including wood and adhesive compounds, without significantly degrading flight performance. Another technical task was to ensure compatibility with available jet engines. BMW 003 was planned initially, but in practice the prototypes used Jumo 004s, which had their own limitations in weight and reliability. A further objective was to reduce visibility to radar and enemy detection systems. Although in the 1940s stealth as a separate discipline did not exist, the flying wing shape and use of non-metallic skins potentially reduced radar reflections compared to classic layouts. Finally, the task assumed manufacturability under wartime production. The project had to fit Germany's industrial capabilities, which required relatively simple-to-fabricate units and the possibility of quick assembly under constrained resources. In sum, the development task for the Horten Ho 229 was framed as creating a multi-role jet aircraft with high speed, long range, and sufficient bomb load for strategic missions, while remaining manufacturable and giving a combat advantage under intensifying Allied air pressure. In practice this collided with engine problems, material constraints, the difficulty of control without modern automatic systems, and a lack of time and resources by war's end, which ultimately prevented the project from entering mass production. Reimar and Walter Horten were two German brothers, engineers and self-taught pilots, whose joint work led to one of the most unusual aircraft designs of World War II. Both grew up in Germany and from an early age were interested in gliders and aerodynamics. In the 1920s-1930s they designed and built tailless gliders and light aircraft, experimenting with wing platforms and center-off gravity placement. These early efforts laid the theoretical and practical foundation for their later developments in the pure wing concept, a configuration in which almost all mass and useful volume are concentrated in a single lifting surface without a distinct fuselage and tail. The Horten brothers were pragmatic. They didn't just argue in theory, they built and tested gliders, learning how aircraft behaved in real flight regimes. Their experience in glider building and experiments with tailless schemes in the 1930s produced a series of projects and know-how in balance calculations, load distribution, and controllability that then formed the basis of the Horten Ho 229, also designated H.9. The Hortens had their own school and a clear vision: reduce parasitic drag, use the wing's volume for fuel and ordnance, and gain speed and range through aerodynamic efficiency. However, the two enthusiasts lacked major production capacity. They needed an industrial base and official backing. At this stage an industrial partner entered the project, Gotha Wagon Fabric, often shortened to Gotha. The Gotha plant had experience in serial aircraft construction and could organize prototype assembly in the required volumes. In documents and in Anglo-American literature the aircraft appears as the Go 229 precisely because of Gotha's role in preparing for production, although the design remained the Hortens and is often listed in technical catalogues as Horten H.9. Relations between the Hortens and the Luftwaffe leadership and the RLM, Reichsluftfahrtministerium, were typical of wartime: initial distrust and bureaucracy, followed by closer study and allocation of resources under crisis. When the RLM announced the 31,000 requirements, ambitious targets for payload, range, and speed, the Hortens project became one of the unconventional responses. The RLM did not always readily fund outsiders and alternative concepts, but as the front situation worsened and pressure grew for wonder weapons, the experiments received support, partly because the Ho 229 promised major advantages in a relatively compact airframe. The key industrial and technical problems were engines and materials. Initially the design called for BMW 003 jet engines, but in reality the prototypes were fitted with Junkers Jumo 004s, widely used on the Mi-262, but heavy and unreliable. Gotha provided production and assembly of structural units, organized supply and vendor coordination. The Hortens continued to oversee aerodynamic and layout decisions. The pure wing configuration imposed special requirements on manufacturing. The shortage of aluminum and priority allocation of strategic materials forced the use of wooden composite elements and layered plywood, which simplified production but raised questions about durability and stability at high speeds and with the vibrations of jet engines. In the industrial political arena the project also faced competition from major aviation firms and well-known design bureaus whose interests did not always align. Large companies such as Messerschmitt and Junkers laid claim to resources, and the RLMS attention their projects were more standard and politically safer to support. Nevertheless, the uniqueness of the Horten's idea and the wartime pressure to find breakthrough solutions allowed the Ho 229 to leave the workshop and reach the prototype stage. At the test phase, flight departments and pilots joined the project plan and emergency tests were carried out. Gotha's role as manufacturer became evident in managing prototype assembly and preparing them for flight trials, while the Hortens retained authorship of the configuration. After factory destruction and the fall of the Third Reich, the remaining work in prototypes came under Allied control. Several aircraft in blanks were taken. One example ultimately went to the United States and for many years was held in the Smithsonian's National Air and Space Museum collection, where it served as an object of study and experimentation in the post-war period. Thus, the authors and manufacturer of the Ho 229 were a symbiosis. The engineering concept and experience of the Hortens as designers and experimenters plus industrial realization and mass production preparation by Gotha Wagon Fabric with the support, and partly under the pressure, of the RLM. This alliance made it possible to turn the flying wing concept into real prototypes, even though the project never saw serial production. The authors of the Horten Ho 229 project were the German brothers Reimar and Walter Horten. From a young age they built gliders and experimented with tailless layouts, aiming to reduce drag and increase wing efficiency. Their early work in the 1930s proved that a pure flying wing could be stable and fly no worse than classic aircraft. They applied that experience to a combat jet when Germany's aviation ministry during World War II set a requirement for an aircraft capable of carrying 1,000 kilograms of bombs over 1,000 kilometers at about 1,000 kilometers per hour. The brothers proposed a flying wing, which made their project stand out among many traditional designs. They did not have a production base to build complex machines, so Gotha Wagon Fabric joined the project. This company handled industrial implementation, assembly, and preparation of prototypes, which is why in some sources the aircraft is referred to as the Gotha Go 229. In the collaboration, the Hortens were responsible for the overall concept and layout, while Gotha provided practical realization and production solutions. The work faced difficulties due to competition with other firms, material shortages, and problems with jet engines, but the project nevertheless reached the prototype stage. Thus, the creators and conceptual authors of the Ho 229 were the Horten brothers, with Gotha Wagon Fabric as the industrial manufacturer and partner. The construction of the Horten Ho 229 was unique for its time and based on the pure flying wing scheme, that is, the aircraft had no conventional fuselage or tail. The entire machine was a broad-swept wing, with the pilot's cockpit, engines, and landing gear located in the central section. The load-bearing frame of the center section was made of steel tubes, providing strength and mounting points for major units. Wing panels, made primarily of wood and multi-layer plywood bonded with special resins, were attached to this frame. This solution was driven by Germany's late-war aluminum shortage but also reduced weight and partially decreased radar reflections. Inside the wing were fuel tanks and control elements, and the wing's mechanization included ailerons and dive/drag brakes that performed lift, descent, and stabilization functions. The pilot's cockpit was built into the front of the central section and covered by a perspex canopy. Controls were standard for the Luftwaffe, but the absence of a tail made piloting difficult and demanded precision. Junkers Jumo 004 engines were placed in nacelles within the wing, which gave good aerodynamics but created cooling and reliability issues. The landing gear was tricycle, with a retractable nose strut and two main struts folding into the wing. The skin consisted of wooden panels bonded with a special adhesive that, according to studies, contained additives capable of partially absorbing radio waves. Planned armament comprised 4 30mm cannons and up to a ton of bombs in the center section, allowing the aircraft to combine the roles of fighter and light bomber. Thus, the Ho 229's construction combined a strong metal core, plywood and wooden panels, jet engines, and minimalist equipment, an unusual mix of future-leaning technology and the constraints of the time. The Horten Ho 229's construction became one of the boldest engineering attempts of World War II. Unlike most aircraft of its era with a classic fuselage tailwing layout, the Ho 229 followed the pure flying wing principle. This meant that virtually everything, from the pilot's cockpit to the engines, fuel tanks, and weapons, was contained within a broad-swept wing. The scheme promised significantly lower drag and thus higher speed and range, but created a host of new engineering problems related to stability and structural strength. At the core was a central section, a welded steel tube frame housing the cockpit, power plants, and landing gear bays. Metal here was essential to provide strength and absorb loads from jet engines and landings. But the center section was only the heart around which the whole aircraft formed. Wide wooden wing panels attached to it. By 1944, Germany faced severe shortages of aluminum and other strategic metals, so using wood and plywood was not just a forced measure but a true production necessity. The Hortens turned the drawback into an advantage. Wooden panels were cheaper and easier to make and partially absorbed radio waves, making the aircraft less visible to early Allied radars. The Ho 229's wing had sweep of about 30 degrees, chosen to reduce drag at high speed and improve stability. Fuel tanks were located inside the wing, increasing range without overloading the center section. Control was via ailerons and air brakes, which simultaneously acted as elevons, controlling pitch and roll. This was unusual and required great concentration from the pilot. There was no conventional tail, so stability depended solely on airflow distribution across the wing surface. For its time, this was a daring, forward-looking solution, but it made flying demanding and hazardous. The cockpit sat in the nose of the center section, small and cramped, with limited visibility, especially downwards and to the rear. The canopy was perspex with smooth lines blending into the wing's silhouette. Instrumentation was minimal, standard for Luftwaffe fighters, basic gauges, a sight, and engine controls. The Hortens sought to minimize weight and avoided complex avionics. The power plant consisted of two Junkers Jumo 004 jet engines. Originally the design aimed for the lighter, more compact BMW 003S, but delays and shortages forced use of the Jumo 004S already installed on the Mi-262. They provided enough thrust to approach 950 km per hour, but reliability was dismal, about 25 hours of engine life. Embedding the engines in wing nacelles improved aerodynamics but complicated cooling. If one engine failed, control became nearly impossible. The Ho 229 used tricycle landing gear. The nose strut retracted forward into the center section, the main struts retracted into the wing. Although modern for jets of that era, takeoffs and landings were tricky due to center-off gravity issues and the layout's quirks. Planned armament was 4 30mm Mk108 cannons in the nose plus up to 1,000 kilograms of bombs. In theory, the Ho 229 could attack American flying fortresses, outrun their escorts thanks to higher speed, and strike strategic targets at considerable range. The skin was one of the most interesting parts of the construction, plywood panels bonded with special resins containing carbonaceous fillers. In the early 21st century, American researchers conducted experiments confirming that this combination did reduce the aircraft's radar visibility to World War I-era radars. The Ho 229 cannot be called a true stealth, but its designers, unknowingly, took a step in that direction. In the end, the Ho 229's construction and materials were a mix of modern ideas and forced choices, a central metal frame combined with wooden wings, jet engines paired with plywood skin, advanced aerodynamic shapes realized with techniques more typical of gliders. The aircraft looked as if it had come from the future yet remained vulnerable due to the limitations of its time. The Horten Ho 229's power plant was one of the most complex and controversial parts of the project. Germany was among the first countries to introduce jet engines into service. The breakthrough came with turbojet engines that made speeds unattainable for propeller aircraft possible. But the novelty brought huge problems with reliability, service life, and production limits. For the Ho 229, the engines were both an opportunity and a weak point. The designers initially aimed for the BMW 003, lighter and more compact, ideal for the slender flying wing airframe. But those engines were in very short supply, production lagged and tests revealed many defects. As a result, the prototypes used the Junkers Jumo 004, the same engine as on the world's first mass-produced jet fighter, the Messerschmitt Mi-262. They were heavy and bulky, which hurt balance and controllability. The Jumo 004 was an axial flow turbojet producing about 8.8 knots of thrust, allowing the Ho 229 to approach 950 km per hour. For the late war, this was phenomenal. Most Allied fighters, even the latest P-51 Mustangs and late-series Spitfires, could not match that speed. Only Britain's jet Gloucester Meteor could compete, and even it lagged aerodynamically. Had the Ho 229 gone into production, the Allies would have faced serious interception challenges. But the Jumo 004 had critical shortcomings. Its service life was catastrophically short, on average 20-25 flight hours before the engine became unserviceable. Manufacturing quality had fallen by the war's end. The lack of high-grade alloys forced the use of simplified materials that withstood high temperatures poorly. The engine suffered from overheating and vibration. Abrupt throttle changes could cause flameouts or even explosions. For the Ho 229, these characteristics were especially dangerous. The engines were embedded in the central wing section, their nacelles integrated into the airframe, excellent for drag reduction but problematic for cooling. Overheating dramatically increased fire risk. Moreover, failure of one engine almost meant disaster. Without a tail and with marginal stability, the aircraft could lose control under asymmetric thrust, leaving the pilot few options. This caused the fatal crash of one of the first prototypes. One Jumo failed, the other overheated, and the aircraft went down. Even so, the speed the Ho 229 promised was astonishing. Calculations and initial tests indicated the aircraft could reach nearly 950 km per hour at altitude, beyond the reach of any mass-produced Allied piston fighter. The famous P-51 Mustang topped out around 700 km per hour, the Soviet Yak-3 about 650 km per hour. Early Meteors barely exceeded 800 km per hour. In essence, the Ho 229 hinted at a new standard of performance that would only become commonplace decades later. High speeds combined with considerable range. Fuel was stored in wing tanks, enabling long-distance sorties, critical for a Germany under constant Allied raids in 1944-1945. The Ho 229 could in theory both defend intercepting bombers and strike airfields and factories hundreds of kilometers away. The Hortens also considered detectability. Wooden skins with composite resins absorbed some radar energy, meaning Allied radars might detect a Ho 229 later than conventional metal aircraft. At 900 km per hour, even a few minutes delay boosted the chance of a successful breakthrough. Thus, the mix of speed and reduced visibility made the Ho 229 potentially revolutionary. But all this remained theoretical and limited to a few flights. The Jumo 004s were too immature for real combat capability. Frequent fires, short life, and production complexity nullified advantages. By war's end, Germany had neither time nor resources to mature the power plant. The Ho 229 remained experimental, flying only a handful of times and never reaching series production. In retrospect, the engines were both the key enabler and the tragic limitation. Jet thrust gave the Ho 229 phenomenal speeds, yet engine unreliability made it too dangerous and difficult to operate. With modern turbojets boasting hundreds of hours between overhauls, the aircraft might have become a terror to the Allies and changed the air war. History decided otherwise. Progress outpaced production, and the nation could not deliver quality at scale. Thus, engines and speed became the Ho 229's calling card and Achilles' heel, a plane that could have been the first true jet fighter bomber of the future, but in practice remained a prototype whose engines burned out faster than the flying day ended. The testing history and fate of the Horten Ho 229 prototypes is one of the most dramatic chapters in experimental aviation during World War II. The aircraft was created under acute shortages of time, resources, and materials. Every rollout to the runway entailed risk and tension. In essence, the Ho 229 lived only a few short episodes in the air, yet that was enough to enter aviation legend. The first prototype, designated V1, was built in 1944 and was an engineless glider. Its main task was to verify the overall aerodynamics of the flying wing, behavior in the air, and controllability without a tail. The aircraft was towed aloft and then released to glide. Tests showed the idea was workable. The machine stayed airborne and handled acceptably, though piloting demanded great concentration. The glider confirmed the right choice of wing shape and lift distribution. The next step, V2, was far more ambitious, a full-scale jet aircraft with two Junkers Jumo 004 engines. The first flight took place in February 1945, when Germany was already nearing collapse. The test pilot was Oberleutnant Erich Ziller. The aircraft took off and showed impressive traits: rate of climb, stability in straight flight, a sense of ample power reserves. The joy was short-lived. One engine suddenly flamed out, the other overheated, and the aircraft began to lose control. Because of the flying wing's characteristics, under single-engine conditions the pilot had virtually no chance to maintain control. The Ho 229 lost speed and crashed. Ziller was killed. The tragedy underscored how unstable and dangerous the configuration was when paired with unreliable jet engines. Work nevertheless continued. A third prototype, V3, was nearly ready. Unlike the previous machines, it was built with combat use in mind. V3 was to receive a full armament of 4 30mm cannons and the ability to carry up to 1,000 kilograms of bombs. But Germany could not finish it. In spring 1945 the front was closing in, factories were heavily bombed, and resources were dwindling. When Allied troops entered Thuringia, where the Gotha wagon fabric plant was located, V3 was captured in a semi-complete state. The Allies grasped the value immediately. The Ho 229 was unlike anything else in the world. It was documented, partially disassembled, and shipped to the U.S. under Operation Paperclip to secure German technology before the Soviet Union could. V3 went to the Smithsonian National Air and Space Museum, where it remains. For years it sat disassembled, but it became the focus of studies that later confirmed its unique aerodynamics and reduced radar signature. Beyond V1 V3, other versions were planned. The Hortens envisioned a two-seat variant, reconnaissance models, even a strategic bomber based on the same wing concept. Some airframes and parts existed in storage, but none were completed. After Germany's surrender they were destroyed or scrapped. Thus, the Ho 229 prototypes had a short but vivid fate. The first glider proved the concept, the second flew and crashed tragically, the third was captured and preserved as a historical relic. The aircraft never saw combat, but it impressed experts worldwide. The British and Americans studied it closely, and many researchers believe the Ho 229 experience influenced U.S. flying wing development, culminating decades later in the B-2 Spirit. The tests brought Germany no practical wartime advantage, arriving too late to matter. But they showed how bold and risky the Hortens' ideas were. They built a machine that looked like it came from the future, yet in the war's endgame it remained an experiment. Even so, those few flights and the prototype's fates made the Ho 229 a symbol of the Third Reich's lost technologies, epitomizing what might have changed the war had history unfolded differently. Horten Ho 229 is often called the first stealth aircraft in history, and this label is one of the main reasons it still attracts so much attention. But it's important to separate the mythology that arose after the war from the real technical features that could indeed have reduced its visibility to World War I-era radars. The Third Reich invisibility plane story is a combination of smart engineering, forced material choices, and later research that wrapped the aircraft in legend. During World War II, radar was still maturing. The British had operational systems in the 1930s, and by mid-war radar stations were a central element of air defense. For the Luftwaffe this meant that surprise raids no longer worked, aircraft were detected early and intercepted. The Germans understood this and looked for ways to reduce radar visibility, although the term stealth did not yet exist. The Hortens did not set out to create a stealth aircraft in the modern sense, but the Ho 229's configuration and material choices inadvertently yielded a lower radar signature than typical aircraft of the day. Form was a key factor. A flying wing has smooth lines without protruding stabilizers or vertical tails, which on classic aircraft reflect radio waves and increase signature. The Ho 229's wing surface was nearly continuous with gentle transitions. Such geometry reduced sharp angles and discontinuities, lowering the chance of strong radar returns straight back to the antenna. In essence, it was a step toward the same principles used by modern stealth aircraft, only without computer optimization or specialized coatings. Materials were another factor. The wing panels and much of the skin were plywood and wood bonded with special resins. In the aluminum-starved late-war economy this was a forced choice, but wood and adhesives reflect radio waves less than metal. Modern studies also indicate that the glue contained additives, including carbon, which could further absorb radar energy. Thus, a serendipitous combination of shape and materials yielded naturally lower radar visibility. After the war, the Ho 229 attracted particular interest from American specialists. One of the surviving prototypes was shipped to the U.S. and stored for decades at the National Air and Space Museum. In the early 21st century, engineers at Northrop Grumman built a full-scale replica to test its characteristics. The test showed that the aircraft had a significantly smaller radar profile than other World War II aircraft. For Britain's chain home radar, for example, it would have appeared more like a smaller fighter, delaying detection. For German engineers, this was not a deliberately engineered stealth effect, but the results were impressive. Still, calling the Ho 229 truly invisible would be wrong. 1940s radar used relatively long wavelengths. You could not hide a large metallic object completely. The aircraft would still show up on radar, its return would simply be weaker and smaller than that of a heavy bomber or conventional fighter. That could buy a few minutes, which at 900 km per hour translates to dozens of kilometers, enough to complicate or prevent interception. But full invisibility remained out of reach. Nor did the Ho 229 have the radar-absorbent coatings used by modern stealth aircraft. Its plywood skin could not withstand high loads as well, and any reduction in signature was more a side effect than a deliberate design target. Moreover, the heavy Jumo 004 engines with metallic parts and hot exhaust plumes would have been conspicuous in the infrared, had such sensors existed operationally at the time. In short, the Ho 229's stealth aspect is that it genuinely had lower radar visibility than its contemporaries thanks to wing shape and wooden materials, but it was not stealth in the modern sense. The legend of the first stealth grew after the war because its appearance clearly foreshadows modern stealth bombers like the B-2 Spirit. In reality, the Ho 229 was an unintended step toward future technology, a lucky convergence of form and materials. Even so, the fact that a 1944 experimental aircraft anticipated ideas realized only 40 years later makes it unique. The Ho 229's stealth aspect is not a myth so much as an exaggeration. It was less visible than its peers, but far from a truly invisible weapon. The third Horten Ho 229 prototype, V3, occupies a special place in aviation history. Unlike the first two machines, which were used to work out aerodynamics and the power plant, V3 was supposed to be the first fully equipped example close to a combat version. Its fate was unusual. It never flew, yet it is the one that has survived to this day and allowed later generations to better grasp the scope of the Horten's vision and assess their technological leap. Work on V3 began in late 1944 at Gotha Wagon Fabrik as Germany's frontline situation became catastrophic. Even so, the project received attention. The aircraft was meant to demonstrate the combination of high speed, range, and serious armament. V3 was intended as the first production standard example. It had a fully outfitted cockpit, provision for 430mm Mk108 cannons, hardpoints for bombs, and a strengthened wing structure. It was to be fitted with two Junkers Jumo 004 jet engines, by then standard for German jet projects. Germany, however, no longer had the means to complete the aircraft. Allied bombing wrecked infrastructure, supplies of fuel and metals were disrupted, factories suffered constant shortages of resources and labor. Nevertheless, by spring 1945 V3 was well advanced, the airframe was almost assembled, the cockpit had equipment installed, and the wings and center section were joined. Just then U.S. forces advanced rapidly into the region where the Gotha plant stood, and when they took the area, V3 fell into their hands nearly assembled. Capturing the Ho 229 V3 was a real windfall for the Allies. American specialists realized they had a unique machine that looked and was built unlike anything of the time. It was immediately documented, partially disassembled, and shipped to the United States under programs to study German technology. Soon the prototype was in the care of the Smithsonian National Air and Space Museum, where it lay in storage disassembled awaiting study and restoration. Interest in V3 flared anew as the concept of low observability developed. Specialists noted the silhouette's similarity to modern stealth aircraft. In the early 2000s, Northrop Grumman built a replica to test radar characteristics, using drawings and measurements from V3 to reproduce the design as accurately as possible. Tests showed the aircraft indeed had reduced radar visibility compared to peers of its era. For Britain's chain home radars, the Ho 229 could have appeared as a smaller target, complicating interception. Today V3 is a prized Smithsonian artifact. Its preservation requires special conditions, since wooden and metal parts degrade with time and humidity. The aircraft remains disassembled, but that does not prevent ongoing research. V3 serves as a window into the past. Through it one can see the boldness of the Horten's engineering and the level of German technology in the war's final years. For historians it is documentary evidence, for designers it is an example of how accidental choices can foreshadow the future. The museum story of V3 also involves public interest. It appears in exhibitions and publications and features in books, films, and documentaries. For the general public, the Ho 229 is often presented as a German stealth, though specialists clarify that we are talking about reduced visibility rather than invisibility. Still, V3's image has become a symbol of an alternative path in aviation that humanity might have taken earlier had history gone differently. Thus, the fate of the Ho 229 V3 is unusual. An aircraft that never flew became the most famous of the series. It became the subject of research proving the reality of reduced radar visibility in a flying wing design, and has survived as an artifact that helps us study the past and understand the roots of modern technology. Horten Ho 229 holds a special place in aviation history despite never reaching mass production or combat. Its significance lies less in practical use than in being an early example of engineering that outran its time. Several streams of progress converged in it: jet propulsion, the flying wing scheme, attempts to reduce radar signature, and the aim to unite fighter and bomber roles. All this made the Ho 229 a prototype that speaks more about aviation's future than its own present. First, the Ho 229 was the world's first jet aircraft built as a pure flying wing. Before it there were only gliders or experimental machines that merely proved tailless flight was possible. The Ho 229 embodied the idea in a full combat aircraft with cockpit, armament, and engines. That novelty made it unique. There was no other machine so radically different from standard layouts. The concept continued to develop post-war, with Jack Northrop's experiments and, later, the B-2 Spirit strategic bomber. Second, the Ho 229 is tied to early notions of low observability. The designers did not intend to create an invisible airplane, but smooth lines and wooden skins reduced radar signature. This only became clear decades later, when a replica was tested in wind tunnels and on radars. The Ho 229 indeed displayed properties that later became the basis of stealth technology, making it a forerunner of low observable aircraft. Third, it was effectively one of the first next-generation multi-role aircraft, combining the heavy fighter and light bomber roles. Planned armament included 4 30mm cannons and up to a ton of bombs. In wartime, that would have made it versatile, intercepting strategic bombers and striking industrial centers and airfields. Such versatility became the norm in the latter half of the 20th century. Equally important, the Ho 229 highlighted the limits of its era. It showed that ideas can outrun technology, but without reliable engines, quality materials, and industrial capacity, even bold projects fail. The Jumo 004s were too unreliable plywood in resin's too-weak 1945 Germany too exhausted to bring the design to maturity, a lesson for the future. Revolutionary layouts demand not only genius but industrial maturity. Culturally, the Ho 229 became a symbol of the Reich's wonder weapons, technologies that might have changed the war but arrived too late. It embodies the notion that history could have unfolded differently given more time and resources. Hence its presence in books, films, and documentaries, and the endless debates among historians and aviation enthusiasts. Modern researchers see the Ho 229 as a direct link in the evolution leading to modern stealth bombers. Its configuration was so unusual and promising that decades later engineers returned to it with new technologies, computers for stability and radar-absorbent coatings. In this sense, the Ho 229 was a prototype of the 21st century that appeared in the middle of the 20th. Thus, the Horten Ho 229's importance lies in its unique position between past and future. It was a product of World War II but conceptually closer to late 20th century aviation. It did not become a war-changing weapon, but it stands as a symbol of how far engineering can go even under dire conditions. The Ho 229 proved the boundary between fantasy and reality can be thin. What seemed impossible in 1944 became the basis for new generations of combat aircraft decades later. That is why the Ho 229 occupies a special place in history, an unrealized project that nevertheless left a mark on the future. Horten Ho 229 is not only a rare experimental aircraft but also a trove of unusual details that can inspire vivid scenes in animation or film. Although it never saw combat, it has accumulated stories and facts that make it seem more like science fiction than a real 1940s aircraft. These features make the Ho 229 ideal for creative reinterpretation. Its appearance evokes UFO associations. Unlike familiar fighters of the time with long fuselages and tails, the Ho 229 looked like a dark, smooth wing gliding through the air. Imagine a scene: a dark shadow like a disc or flying arrow appears above the clouds, and Allied pilots panic, trying to grasp the new threat. Contemporary accounts noted the Ho 229's shape made a strange impression, as if the aircraft did not belong to its era. Another curious aspect is the mix of cutting-edge technology and almost primitive materials. In one machine, jet engines, just beginning to change aviation, were combined with a wooden skin bonded with resins. Visually, you can stage a contrast between the fiery exhaust of a jet and the fragile-looking plywood wings, the drama of a future machine built from the materials of the past. The tragedy of the V-2 test flight can form the core of a dramatic scene. Pilot Eric Ziller feels the machine's power and speed. Suddenly one engine fails, the other overheats, the aircraft rolls into an uncontrollable bank. It's the moment when a promised warchanger dies with its pilot, leaving the taste of an unrealized dream. The surviving V-3 offers ample room for imagination. It never flew, yet became the sleeping giant that waited for decades under museum tarps. A dim hangar scene with a mysterious black wing under canvas can symbolize a forgotten technology rediscovered years later. Modern-era research also adds drama. When Americans built a replica to test radar visibility, it indeed showed stealth-like traits. This is a bridge between eras. Engineers in a contemporary lab watch test results and realize 1940s designers unwittingly anticipated the future. In animation, you can visualize this by flashing the B-2 Spirit's silhouette beside the Ho 229, revealing their kinship. Because of its unusual shape, some Allied soldiers who saw photos compared it to a flying saucer, feeding myths about Nazi UFOs. In animation, Allied pilots could mistake the Ho 229 for an unidentified object. Sound adds texture. The Jumo 004's piercing whine was notorious. Picture a night raid. A strange screech rises over Allied positions, heads tilt upward as a tailless dark wing streaks past, amplifying fear of the unknown. In alternate history scenes, the Ho 229 could intercept B-17s, outrun P-51s, or even strike London, setting classic WW2 aircraft against a machine that looks imported from another era. Finally, the museum legacy is inherently cinematic. Today the Ho 229 V3 is in the US, where thousands come to see it. A child gazing at the dark wing and imagining it in flight ties past to future, a perfect closing image. Thus, the Ho 229 is more than a prototype, it is a source of plots and imagery. Its shape, materials, tragic fate, and museum afterlife make it ideal for dramatic, fantastical, and alternative scenes. History, myth, and imagination converge, inspiring not only historians and engineers but also artists, animators, and directors who want to show audiences a plane from the future born in the past.